Just getting the YouTube stream up and going. Okay, there we go. Pin that. And so we're probably gonna, in our idle time, do some more complex analysis studying. Where did, oh yeah, we've been talking about series. Let's go into some more of these. Oh, you know what, Zach? I should tell you, since I've just gotten to complex series, I'm even more thankful that I did your series class, because like uniform convergence has been a big thing in this like chapter so far, and it's been really helpful to already have that understanding of what it means. Actually, maybe I should go back through those notes because I do want a bit of a refresher. But there's also another thing which is helpful, which is the Weierstrass M test came up too. So I guess like thanks again for holding that class. But yeah, you know, instead of doing this, maybe I do want to go back and dig up the notes that we took on uniform convergence for real analysis. And maybe retry a few of those proofs. I just need to remember what part of the class that happened in. Not that one. It's Taylor series, so probably earlier than that. Hey, Katabuchiha, are you the only one? Like the only one here right now? Probably. I only just started. Oh my god. This isn't this isn't the right set of notes, but I just have to give another shout out to this joke that Zach made. I choose you, Pikachu. Oh my god. That's true. Zach did get first. He hasn't actually typed this. I wonder if he just like got first and dipped again, which would be funny. Hey Sage. JE questions. I can't really do JE questions. I'm sorry, Sage. And Slim, thank you so much for the raid. I hope your stream was good. Oh, you're just making fun of me, Sage. Okay, that's fair enough. Sorry, I hate telling people no for that, but I have a reason for it. You failed at a complex integral. Do I want to solve it? Oh, I think I saw it posted in your Discord. Was it? I could try my hand at it. I've literally only just learned it though, or learned about like complex integration. So I don't know if I can. Okay. This set of notes might be the one that I was looking for. I'll look at Slim's integral first, but what I was doing just before you guys popped in was looking through the notes we took. I don't remember when this class happened anymore. It apparently happened this year, but also late last year. The real analysis class that Zach taught, part 2 of it, about infinite series. This has been very relevant to the complex analysis that I've been learning about, and I wanted to go back through some of the problems for uniform convergence. I can't find where these freaking notes are though. Okay, I think I found them, and I'm a little bit behind on chat right now. I promise I'll check it in a second. Zach, what was the we fail? So something that I've met a Japanese girl and asking her to say Pikachu. I choose you. That's you, alright. Yeah. Like the Beach reference. I don't like finding out what the lyrics were. Oh yeah, I've had that going for like maybe this is the 5th day or something. But yeah, Zach, I was talking about it before, but actually, I mean, maybe you had to do a pre-roll ad. I forget that those things happen. But with the complex analysis stuff, we've been getting into series, and I've been even more thankful that I took your infinite series class now, because it talks a lot about uniform convergence and the Weierstrass M test, and so taking your class has been a big help in learning this stuff. So I just wanted to say thanks again. There it is, Weierstrass M test. And so I was digging through the notes that we took just to try and go back through some of these proofs for real analysis. But I think we'll try Slim's integral first and probably fail. But did I read some Lemony Snicket? I'm pretty sure I read a series of fortunate events as a kid and saw the movie. Yeah, I definitely remember reading it too. The movie's already, oh, I forget how it ends, but like it's already a pretty depressing situation in the movie, and it's 10 times more depressing in the book. Like the old dude will not leave those kids alone. I think the class about complex variables and you designed it. There's very significant overlap. Oh, that would have been cool too. On Tuesday, we spent literally like an hour and a half just talking about the convergence of sine of z over n, and whether it's uniform or not. Probably starts at n equals 1. First, we brought on Slim to rescue us, but then he got confused too, and then Collar Cone, we brought him on, and he finally rescued us with help from Slim also. That was a doozy, and I need to go back through it just to be sure that I understand it. The Netflix TV show is actually pretty great. Oh, I didn't realize that they made a Netflix show. Check the PDF I shared. Oh, no, I downloaded it. I didn't have a chance to look through it, though. So let me write down what Slim's integral is, just make sure I'm copying it down right. Minus infinity to infinity cosine ax over x squared plus 1 dx. But I definitely want to open up the book that you sent and look. If they talk about branch cuts, I definitely want to read everything I can about like branch cuts and branch points. Because I haven't seen an explanation of it that I've quite liked. It might just be a hard thing to explain. Fembox? Wait, isn't it my normal time? I'm pretty sure this is my normal time. On Tuesday, I start them late. Coming Office played by Neil Patrick Harris. Ooh, that's a good pick. Movie only covers like 3 of the books. TV show does all the books. It's already 4 there? Oh, okay. So, the idea of this integral is that we need to use complex numbers. And so I haven't learned residues yet, and so if residues are helpful for this problem, I'm just going to be... It's not going to be possible for me to do this problem yet. But I think the general idea with applying complex variable techniques to a real integral is that we can think of this integral goes from minus infinity to positive infinity. So if we draw that on the complex plane, that's basically following this path here. Oop. But what we also know is that as long as we're not enclosing a pole, the integral around any closed loop is 0. And so what you can do, instead of considering the actual thing that we want immediately, we could consider, for example, a semicircle like that. And so this piece on the bottom would correspond with the actual bounds that we want if we make the semicircle in like the radius infinitely large. But we start with it being finite and we would take the limit later. The point of doing this is that this path up here goes through like imaginary numbers as well. And as long as we're not enclosing a pole, we know that an integral around a closed loop should result in 0. So we could equally as well integrate just this top piece and know it should be, I guess, the negative of the bottom piece. But here I have enclosed a pole because we have poles at plus and minus I. So depending on the radius of this semicircle, we'd have a pole there and a pole there. And so, I mean, we should, like, presumably as long as it's, well, I assume that we still know what the result of the integral is, right? It should just be 2 pi I, unless I'm mistaken, but let's run residues because you also don't know. I mean, I want to build up the residues though. I just want to skip right to them. That'll be in like 2 weeks though. It won't be long before I learn them. And so we can also say, if we want to avoid the pole entirely, we can notice that this is an even function inside here and consider 2 times the integral from minus infinity to infinity. No, from 0 to infinity. So you did, so we must have the calculation of the residues. Okay. And so instead of doing the contour that I drew above here, you like skipping the backtrack, no patience. You like that instant math gratification. We could consider a different contour. One that, like a circular sector wedge, like say at a 45-degree angle. Because I was just working a problem off stream that involves a contour like this. And if we can work out these 2 pieces, we know what the bottom piece must be, because now we're not enclosing a pole. So I think this would be the path that I go down first. The only reason that I thought of this is that I literally just did a problem that used this exact contour. And they said to use this contour. They did it with something that looks like the error function though. So it was a very different situation. Problem is that maybe the line integral over that line is hard to calculate as well. The integral of the semicircle is 0, which makes things easier. Well, the semicircle isn't 0, right? Because we're enclosing that pole. But yeah, the integral on this line might be hard to calculate, right? Because we're basically stuck integrating this exact thing. But if we have the advantage of being able to put things in exponentials, maybe we get some identity or something. Just a semicircle without the real part has integral 0. Oh, that's what you're saying. Yeah, not the closed loop. Wait, does that have integral 0? I don't know why it would. Can we use e to the IAZ? The real part is cosine AX, Bourbaki says. Well, Bourbaki, I guess we're debating what contour to use. Then use Cauchy residue theorem. Problem with me doing this problem is that I haven't learned Cauchy residue theorem. Tend to as r goes to infinity. Oh, I don't have any intuition for that, so I'll just believe you. So yeah, Bourbaki, you might have a good idea there. I'm only really just learning this stuff for the first time, and I don't even have the full toolbox, so I haven't learned anything with residue yet. I just know generally if you enclose a pole, you usually get 2 pi I with your contour, but I was about to say something. But yeah, you might have a good idea there. I just don't know exactly what it means. Color is Zach to explain it to us. So when we learn residues. I mean, Zach is doing the 100 integrals sometime soon. Just throw this one at him. Although I think he's choosing his own problems. I just want to see for myself why this contour is not necessarily a good idea. So I just want to investigate it a bit. Say C1, C2, C3. My light is bothering my eyes. Let me mess with it. It's a little bit too bright. Is that even... Oh, that does make a big difference still. Okay. You know what? I think this might actually even look better than I had it before. You know what? Okay. Let's... Quick lighting test. Oh, yeah, you know what? I think I like it the other way around. This is too bright, I feel like. Oh, you know what? I should test it during the night also. But I think this looks better. Okay. Actually, during the night, that should only be more noticeable, I guess. So maybe I should just have it like this, because I usually have my light shining directly on me, but what I just did is I turned around to face towards the wall. Because for whatever reason, on some days when the light shines right on me, it just kind of bothers my eyes. So some days it doesn't, so I don't really know what causes it, but anyway, what am I doing here? I guess I'm looking at... I guess we'll look at C2 first. So we'll parameterize this with polar. Here, I'm using capital R to say that R is a constant. Yeah, Bourbaki, that was the kind of first thing that I thought of. Is the result of the entire loop 2 pi I though? Or what's the deal with that? Pimanu, yeah, that's a good way of thinking about this stream. What's the complex the definition of cosine? I can never remember it. Actually, wait, can I remember it? E to the IAZ plus e to the minus IAZ over 2. I think that's right. Oh wait, I'm stupid. I'm gonna get e to the e here. Let's just see how it looks. Let's not give up immediately. I'll give up slightly after immediately instead. Okay. What do we do with you? If there's not some immediate use up here, this is probably worth giving up on. You can prove that goes to 0 as r goes to infinity. I still have no clue. Oh, as r goes to infinity. I guess so. I don't know. Yeah, we still have the r up here in the exponent though, so it's not completely clear to me. Oh, the numerator is bound because it's cosine. Okay. Just take e to the IAZ, and after integration, we'll take the real part of the result. I don't know how to integrate it if it's e to the IAZ though. Jonathan, that's not strange. I use a Huion tablet. It's just a cheap thing I bought off Amazon. I can get the exact name of it if you're interested. I don't have it immediately, but I know where to find it. I didn't do very much research into it. Finlux, this is from Slim. So you probably saw it in his stream. Also, you're over on the YouTube side today, like mixing it up. So Bourbaki seems to have so I'm gonna call this a seemingly dead end. Bourbaki seems to like something about... I keep adding the circle where it doesn't belong. about the look of this integral over a different contour. I think Barbaki is talking about the semicircle idea. Zero to 10 pi, Abimanyu? Oh shoot, I didn't even see your previous message about that trying to be a regular. I really appreciate that if you do. 10 pi is an interesting choice of cutoff. That doesn't seem natural to me at least. But yeah, no, I'm very new to complex analysis, so and complex integration in general, so you may have a good idea there. I'm just not the best judge of that. Okay, so this is the semicircle idea. But I assume this is the same exact question, right? Oh, okay, they're only doing half the interval. Came over to watch Gold. Oh, nice. Yeah, I had his Gold Twitch stream open, but I saw he ended after like a minute or two, so. He's on YouTube right now. Okay, okay. Oh, residue stuff. So I don't know where this is coming from. Okay, that probably is helpful, and it looks like it kind of matches where I assume Barbaki was taking it. I think I'm just going to move on though, because I feel like I don't have all the tools to solve this question, to be honest. Oh, that's interesting. So Slim, this person is contradicting what you were saying. Or well, yeah, I don't know. I think I'm gonna just give that one a rest then. And unless someone has a question they want to talk about, I think maybe I'll go back to my original plan of looking at uniform convergence in the real analysis context. Trying to do too many things at once. So I'm trying not to look at the notes that we took around here. You know, let me pull the, well, I don't feel like pulling the problem set. I'm just gonna take a screenshot of this. And watch kids, and get permission for July 3, and trying to figure out stuff with respect to our car, and just life. Zach, I have no clue how you do it. You have way more stuff going on in your life than I have going on in mine, and you manage to accomplish so much more in your day. I have a lot of respect for that. Okay. So let's think about this series here. We have made no code progress except to refresh my bot code and change a few colors. There are so many projects that I just haven't even started that I really want to start. But every time it comes time, I'm just like, man, I just don't feel like it. So we have x to the n over n plus 1. It looks like a geometric series, but with an n plus 1 dividing it out. Oh wait, this one might be helpful to draw out the first few functions. Or maybe Desmos out the first few functions. Problem 5 from section 2.5. Really? I didn't realize the problem was in there. Okay, so this is the problem that I'm pretty sure I was doing off stream. That's where I got the idea for the contour, but this is a different function. Is this the error function? I might have meant to say something that looks like the Gaussian, like the bell curve. The error function is something else, right? I don't remember anymore. But yeah, that's one where I got the idea for the contour, because I just was given it from that problem. So our first function sequence is 1. The next function, the next function in the sequence is 1 minus x over 2. And then, oh wait, sequence. X squared over 3. That's not 3, or 2. The pizza slice shaped contour, yeah. Integrating over a pizza slice. I love it. I'm missing a negative. Interesting. Okay, so this is doing one of those things where seemingly between 0 and like negative 1.25, it's flattening out to 0. Maybe it's just negative 1 even. What's happening on the positive side? The positive side, it's kind of all over the place. And that makes sense because it's an alternating series sequence. And the negatives align with the odd powers. So inputting a negative number will kind of fix the signs so they all match on the negative side. Yeah, we should be able to find some interval where it converges to 0. Maybe even that goes into the positives too. I don't know yet. So, well, the hard part is we have to say what we think it converges to. Gonna run home? Run home? All right, sounds good, Fembox. I guess we're gonna say it converges to 0. For the reason, like, I feel like this is a lot more natural and we're. I guess it's because I'm coming back into it cold. I feel like I don't remember having that much trouble with it. Hey, collar cone. I think I don't remember having that much trouble with this problem when we were doing it during the class. Hey, Shreya. But it does feel like x being between -1 and 1. There should be something magical about that, or something like that. Bourbaki suggesting the root test or ratio test. I don't remember if we had that at this point in the class. Like, we can just do it though. I think ratio test implies uniform convergence, right? Like it's that good. Not right now, no, Shreya. I'm starting a master's though in the fall. I want to do an epsilon delta thing, but this is a good thing to investigate first. Oh, is it only point-wise for the ratio test? Applied math, Shreya. Ooh, speaking of, I did just register for my classes at the beginning of the week. So I did get into the more advanced complex analysis class. I'm doing scientific computing and I'm doing mathematical biology. Armand. Pre-uni is fine. I don't go live daily though. Like right now are usually my free days. So for me, it's Thursday. Depending on your time zone, it might be Friday for you. I'm live on YouTube. It's always hard to communicate times when people who are in different time zones. But I'm usually live like today, right now, on YouTube, and then 2 days ago and 2 days in the future, whatever that is for you. For me, it's Tuesday, Thursday, Saturday. For you, it might be Wednesday, Friday, Sunday. When you're planning to move out, I think I actually have a date set now for that as well, which is August 18th? Question mark? Let me see. My mom was helping me move, and so we kind of based it off her schedule because I'm fucking unemployed and don't have any obligations anyway. So, okay, yeah, August 18th. So around then, my stream is gonna go dark for a while, and then I'll change my schedule and stuff. It's 2 a.m. Yeah, I have no clue why, but there's quite a few people, especially in the YouTube chat, who come around despite it being at the stream at a terrible time for them. Uniform implies pointwise in general, or there's another exception I'm not aware of. This is classic in analysis. I'm pretty sure uniform implies pointwise. I sure hope so. Come to the math bio side. I've been on it. The thing that, or one of the things that really inspired me to get into math was when I was a research assistant applying, and the project my professor was doing was applying the SIR model for the spread of disease to like viral social media trends, and I thought that was really cool. Uniform implies pointwise. For general LP convergence, you may not even have pointwise convergence. Ooh, it's fancy math. Why complex first and not the core ones like real, complex, and algebra? Because I'm a degenerate applied math enjoyer, Dessen. I'm not like you, so I just don't have to do analysis or algebra in general. The complex analysis class that I'm taking is like a very applied to complex analysis, where we're going to be looking at like fluid dynamics and stuff like that too, I think. No, I did not find a place already. My plan is just to roll up there and try to sign an apartment quickly, because I don't really know how else. I don't know. It's like a 2-day drive, so I never had to just like show a place and sign it at least on the spot. When I was in college, I mean, I guess I kind of did that in college, but I always had a place to like crash. Armand, yeah, I'm sorry about that, but yeah, the JE questions are, I've tried them before and they're just not easy. School for PhD so it can be roommates. I mean, the school I'm going to for a master's is University of Washington. I'm planning to apply to stay on for a PhD. If I don't get in, I have literally zero plans for what I'm going to do. I really don't know. What are you studying the math bio thing? That's a good question that I always forget, but I think part of the class is about kind of like macroscopic, like modeling the population change of species. And I think part of the class is more like microscopic, like where math can come up in like brainwaves or some shit. I can't remember exactly. I could bring up the actual course description again. It's likely they won't take you for a PhD. That's the spirit, Dessen. That's what I need to hear. Trust me, I am very painfully aware of how hard it is to get in for a PhD. I've tried multiple times. Applying while you're already a master's student gives you better odds, but there's still very bad odds. Enzymes, maybe. Oh, that's interesting to know. Phobos, hey. Hey, current of 2 amps flows in resistances as shown, potential difference VA minus VB. That looks like there's an image involved with that ROM. I don't really know what the question is. Looks like someone's now well versed in the Twitch language. Yeah, they study math or biology has no link whatsoever. And Shreya, in my mind, that's a shame because mathematical biology is kind of cool. That's interesting, Destin. So at least from what I've heard from like the graduate program coordinator people is that like out of the 25 internal applicants, they tend to accept about 2, I think. Which, as terrible as those odds are, it's still a better percentage than the general applicant pool. So I don't know how exactly they think about it there. But it's still better odds. But I don't really plan to. I mean, I might. I don't plan to try to apply to a bunch of schools again because it's very stressful and I'm gonna be working a master's during that time. So if I don't get in, I'll probably just try and get a job. But I don't really have like firm plans. Corpin is a hobby of mine. We're all gonna be the guy who sits on the side feeling like imposter syndrome on Twitch. That's kind of what it means to be a Twitch streamer. Honestly, especially for math, but not even for math in particular. People who do their MS and PhD at the same institution. Yeah, I feel like it's not that uncommon to continue on for PhD after an MS. It is frowned upon to do a BS, MS, PhD at the same place. Really? I hadn't heard that. But like, what if you just really like it at that school? Or like you have a really good professor who can like guide you all the way through? I don't have any personal objections to that. It's kind of interesting to hear that because I never heard that before. And the master's program there is just a 1-year thing. So like you barely spend any time there before you graduate for a master's. Welcome back, Fembox. So welcome to your PhD at the Academy Useless Ideas that agrees by all my family members. Where is it? I have to show it. Slim, I am absolutely down to take classes in exchange for fake degrees. Exhibit A. This is from Zach for the first real analysis class. Did I ask him to draw a dinosaur? What is that? Oh, it's the seal of approval. Yeah. This is the seal of approval. Oh, shoot. I changed my name. Oh, no. It's not even my degree anymore. It's Donda's maths degree. Yeah, there's a more formal looking degree also. I should really, honestly, I actually do want to like frame these. These are a nice like time capsule of a good time. Yeah, I have to retake the class now. The mathematics, it's literally killing me, Shreya says. I'm gonna survive. I'm sorry, Shreya. I promise you it'll get better eventually. Programmer Ianot. To be honest, I've kind of just gotten distracted and I'm just like yapping right now. But I still want to think a bit more about this question. Hey, IVK. I do remember you. Taking a drop for the JE. I'm not sure what that means, but good luck with it. Give you a 3rd degree, no class required. Hell yeah, Phobos, I'll take it. Items like it sometimes is your only option. Yeah, I bet. For almost. Oh wait, I'm. Oh, okay. let me scroll up and chat, because I missed a bunch of chats. At my university, they already wanted me out. Oh no. Bruno almost said that his MS advisor wanted him to work with someone else because his advisor had taught him all he could. Ooh, wow. Be able to see the world is to avoid inbreeding. That's fair. What is recommended would be having a 5-year program with MS included. Fair, yeah. I mean, that's what I applied for. They only accept me for a master's. Degree reissue, yeah, box. Oh, true, yeah, I forgot that there's still the one for Infinite Series. I forgot about that. Gonna be next to the PhD degree. Honestly, yeah, with an unsolved JEE exercise. Proud shame. Build a change of name form with each of the 2i Pi enterprises. That has to be a registrar. BA plus MSc. Oh, I haven't heard of that type of 5-year program. Make sure you're beyond high school, like 12 grades for the exam. Oh, wow. That's crazy, IVK. Who, yeah, I remember your name. Hands on mathematics, computing branch, want to go into quants with AI. It's probably a pretty lucrative thing to get into. I don't know much about it for myself. Yeah, I expect Zach to have a very like bureaucratic form to fill out in order to get this name change. How much are they charging per credit? So that's the thing that's the part of the degree that kind of sketched me out is when I went to like an information session before accepting the offer. One of the first things that they said was, yes, this is a real master's degree at University of Washington. I was like, okay, well, that wasn't a question I had before, but now it is. It's not structured like a normal degree, though, which kind of, I have no clue why. I think applied math just isn't respected or something. Or, I don't know, it's more geared towards industry jobs rather than academia. But it's like considered a professional continuing education program or something like that. And so they actually charge a flat fee just for enrolling at all. They do not charge per credit. So if you take one class, they charge you the same as if you took 5. It's like $6,000, like like $6,800, I think, for 1 quarter. Phobos, yeah, I accepted. I registered for classes even this week. 9:15, you were on 3 like a week ago. I don't think streak counter on Twitch. Oh, really? I don't know. So you need to watch your team before you know life and stuff. Fair. So thesis is optional, and as far as I know, I haven't actually heard of there being a qual, which I never thought about until you mention it now. I think the only degree requirements are just getting enough credits to pass. Maybe that's why it's in a different category, because you don't take quals. But I think as long as you have the GPA and the number of credits in a certain particular few classes, I think that's all you need. So that might actually be the answer to the question for why it's a different program. Getting actual jobs respected in academia? I don't know, Color. I feel like the entire program I'm in is... I feel like applied math programs in general don't get very much respect. And I feel like one that's geared towards... or I don't know, yeah. Like the applied math offices there, I went to visit them, and they're pretty, like, bad. There's a weird smell. It's just kind of stuffy in there. The building is kind of old. Like, it's not bad, but it's like... I feel like if I went to the regular math department, it would be a lot nicer. Applied math is different. Pay to win, that's sus. Similar to CSC with more maths and proofs and all computer science. Okay, that's very ABK. It sounds cool. Pay to publish, I bet. Okay, so You know, I might look at the work that we did on this. I was trying not to look at it, but I kind of want to look at it now. Oh, that's how we're thinking about it? Oh, wait. Should I pull from an earlier one? We're not epsilon delta-ing here. Or epsilon n-ing. Maybe I might need to go earlier. So we just took the literal limit. And checked the endpoints. Did we say uniform or pointwise? I don't think we actually wrote that down. It should be uniform on this interval. Because it should be bounded above by +1 for x, right? So I'm going to suspect that it's uniform on this interval. So we should be able to epsilon n this, right? I don't know why we didn't here. I don't know what this thing is here either. Okay. If I try... Can I try to formally prove uniform convergence? This might not be a good idea because this one, it looks like we weren't intended to use the definition, apply the definition directly here, but let's see if we can do it anyway. Oh wait, this is a series. So we need to think about a sequence of the partial sums. So when I was looking at this in Desmos, I actually should have been adding them. That looks more like it's gonna approach something. Is it 1 minus x? No, I don't think it is. Okay, so this might be one of those where it's hard to say what it's approaching. I mean... Okay, so, you know, let me actually just back up and pull from a different problem set. How does this one look? Okay, these look more... a little bit easier to apply our definition. I want to... Okay, you know what? I'm just going to pull from the actual problem set. This is getting a little messy on that note sheet. There we go. Okay, so let's look at part A. Part A. This thing, it should be approaching 0 as n gets very large, right? I hope that's reasonable to say. And so this might be one of those things where, well, probably x equals 0 would give us kind of like the upper bound that we'd want. Oh wait, no, what's actually happening with this sequence of functions? As n gets large, this is shifting. I remember, I think, talking to Phobos, or like working on this problem with Phobos. What were you saying? So what n is doing here is it's shifting. If this is when n equals 0, just regular graph of 1 over x, the n is shifting us to the left. So basically the curve is going to go all the way to the left as n gets large. And I think the rationale is that as it shifts to the left, if we keep looking at the origin over here, it's going to look like it's going towards 0 because it levels off here. And so if we keep dragging that part, that's leveling off closer to the origin. It's going to look like 0. So that's what we want to think about, I think. And I think x equals 0 would give us our upper bound. You remember the power series? We were doing, like on Tuesday, we were talking about sequences of functions, right? Because like the one we spent so much time on was sine of z over n, right? What I'm doing with the problems that are on screen is these are from the real analysis class that Zach taught early this year and late last year. I just wanted to revisit it because this is where I first learned about uniform convergence, and so I just wanted to kind of review some of these problems and remind myself of the definition in like the real analysis context at least, which it's the same exact thing, but just gonna remind myself how these epsilon n proofs actually work. Can I say this statement is true? Wait, do I want to say the statement is true? Yeah, we can make 1 over n arbitrarily small. So I think we can make that chain of inequalities, right? Or equal to. When x equals minus n, the thing on the left blows up. So it cannot be bounded by 1 over n. I think what I haven't done a good job of saying is that I think I'm trying to claim uniform convergence for x greater than 0, maybe, or equal to 0. And so I think that's how I'm justifying this bound. Yeah. So at least for the sake of uniform convergence, I haven't actually written that out anywhere. I guess we can say that though. Okay. Like this, maybe is what I want to say. And so this is like, this part right here is, I was getting confused on like this same idea on Tuesday when we were talking about it with sine. But I think just in general, if we're given a random epsilon, we can always make 1 over n smaller than that epsilon. So we start with this, and then we make this claim second as like the flow of the formal proof. So I should do that separately. Oh, really, Sock now? Hey, Lucas. Okay, so yeah, I wasn't sure what your experience was, and so I didn't know. I was kind of assuming that you maybe hadn't seen it ever before. Yeah, Lucas. Every time you come here, it's epsilon. So I kind of assumed that you had no experience, Sock now. So if I was wrong to assume that, then my bad. Okay, good. Color cone. Oh wait, so Lucas, if you're talking about like, or if you're talking about the problem that's on the screen, this is from Zach's real analysis class. It's not from a particular book. I could try and find an analysis book if you wanted an analysis book. What I'm talking about with Suck now, I'll show on screen. It actually, I kind of really like the look of the book when I was looking through it. And if you want this book, I can definitely give it to you, Lucas. This is like an introduction to proofs. This book is free and legal to use. I don't remember the exact license, but it came from an open textbook library. Yeah, it goes over like introduction to set theory, logic, and then the counting part was kind of surprising to me that they would include this, considering it's building towards calculus somewhere. Or it seems to be building towards calculus, like here. But counting is a generally important thing, I guess. No, not particularly in number theory, although it's going to come up in some of these proofs. This is more about just how to prove things in general. And they do start off with like a baseline of like what language you often need for proofs. Let me dig up the link. 1 second. Because I sent it to SOC now. So yeah, that's book there. You can just download it with that PDF button. But yeah, so now, if you already know like this fundamental proof, you probably can just go straight to real analysis if that's what you want to do. Which I don't know of a good real analysis book off the top of my head, but that's something I could look into if you want. I'll probably pull it from the same website, to be honest, because it's just a nice website. But yeah, so I was just like guessing that you had very little experience with proofs, so I was looking for something that was like introductory. So sorry if that was wrong. Took logic in college using Paul Herrick's Introduction to Logic. Like, I do have familiar with it. I took logic to replace my mathematics because I was in philosophy. Okay. You know a lot. However, I'm trying to get into using calculus for economics because I really want to see behind the scenes. Ooh, that's cool. So yeah, if you want to get it, like, even for economics, I'm not sure that you would need to know the actual, like, I don't know if you need to get super deep into the theory of calculus. It probably helps some, but just knowing like what the concepts are, I would bet is more important. If you still just want to get into the proofs of it, like I would just go back to this website and search, or even just look in the categories, probably better. Like the theory of calculus is called real analysis, and I saw a few books. Yeah, okay. Analysis. Numerical analysis. We want like a primer of real analysis. Or mathematical analysis, I bet was good into calculus. Yeah. Like this one is just a straight up real analysis book. So there's quite a few options for analysis on this website too, if you want something that's a bit harder. They might even have just like econ calculus book in general too. I don't know. It might be in the applied math part. And yeah, Lucas, if you want, you can try to solve the question that I had up. I'll show it in a second. Satya, I am a-okay. I would prefer not to. James Stewart, I'm pretty sure I have. I haven't. A calculus class I've taken at some point has probably used it. Do you also have fake analysis? That's basically complex analysis. That's why they make the distinction. So real analysis just deals with real numbers. Complex analysis includes complex numbers. Yeah. So Sakno, if you want something more from me, let me know. But otherwise, I'll just leave it there. Because this website, like, if you ask me for another thing, I'm probably just going to look for it through this website. Because I like it. So yeah, Lucas, the thing I'll warn you is doing epsilon n proofs with this stuff down here. These are sequences of functions which are a little bit different from the sequences of numbers that you've probably seen before. So it's the same fundamental thing, but instead of saying that, or you know, if a sequence of numbers like 1 over n converges to 0, a sequence of functions might converge to a different function. So that's kind of like the main difference. But other than that, it's pretty similar. I don't really like this song that's playing. And then another thing as with functions is that you get two different ideas of convergence as well. Descartes coined the term real numbers to dismiss the imaginary numbers. There is no fake analysis. There's also complex. Yeah, okay, yeah. A level for the math? Yeah, those questions aren't easy, but I can usually do them, yeah. Harmonic series. Oh yeah, the harmonic series that diverges. 1 over n as a sequence converges, though. No, not like asymptotes. It's not a sum proximity. It's a sequence of functions. Yeah, let me look through the notes where there's an easier example. So this is from like later on when we had already. What was this sequence? Ooh, okay. Yeah, that arctan one is fun. Okay, so let me. So I'm looking at part B here, arctan nx as a sequence. I'll write it so it's bigger here because I don't know how it comes across on stream. Arctan of nx from n equals 0 to infinity. Let's graph this in Desmos. So we made a little sketch of it here, but it'll be, or here is probably better, but Desmos is a lot better for this. Let me do a separate Desmos. That one is kind of messy. Oh, inverse tangent. So like it's also tan to the, or depending on how you think of the -1, it's the same thing as like tan to the -1. I say arctan to avoid confusion with no. It's different from 1 over tangent. It's a really confusing thing. But inverse tangent is different from 1 over tangent. It's terrible notation, but I'm talking about if tangent of an angle equals some, or I guess tangent of an angle equals adjacent over opposite over adjacent. Then you can take inverse tangent of each side. Or arctan is the same thing. To solve for theta. So inverse, it's a functional, or it's the inverse function, not 1 over. So like inverse tangent of tangent cancels basically. There's a subtlety there, but inverse in that sense, not 1 over tangent. That's cotangent. Oh, Lucas, the inverse of x squared. So if f of x is x squared, the inverse is root x. Like, well, plus or minus. So that's the sense of inverse that we're talking about. You want to use logical proofs for economics so you can see market fallacies, then it allows me to criticize markets rather than people telling me, oh, it's not how the economy works and shit like that. Oh, interesting, Sock now. Yeah, so... That's an interesting end goal to have. It might be the analysis what you want, but you might be interested in more just general kind of logic and proofwriting, not necessarily... Like, you probably want to know some of the theory of calculus, but if there is an existing field of study for what you're talking about, I don't know what it's called, I guess. You probably have to make it up as you go. And just, like, study logic and proofwriting on one hand, and then also study economics separately, and then try to combine them yourself. That's my bet. I imagine that doesn't really exist in a big way. Yeah, so like the procedure is you would switch. So like if you have y equals x squared, if you want the inverse, you switch y and x, and then you solve for y. So you take the square root of each side of that. And so you can do the same thing with trig functions. If you have y equals tan x, you can take inverse tangent of each side. Or sorry, let me back up. You can still switch y and x, and then solve for y by taking inverse tangent. But it's completely different than 1 over tangent. And it's very confusing. So if you find that confusing, you're right. It's a place in math where our notation is terrible. One of the places. People use game theory to justify some economics models. People use math for a lot of economics. Oh, I bet game theory would come up. Yeah, I can see that. And so if you ever oh, 750, you got a diploma in what? Congratulations. You think you understand? Okay, good. Yeah, if you ever study abstract algebra, they really drill into the idea that you can have an additive inverse, or like, you know, there's an inverse for addition, there's an inverse for multiplication, an inverse for functions. There's inverses in all sorts of like senses of the word. And you have to be really specific in what sense that you're talking about it. And that's the exact same issue that we're having here. Yes, exactly that. You finished high school? Hell yes, it's 750. Congrats. Are you planning to go to university, or take a break, or get a job, or what you thinking? And yeah, so Lucas, the thing that you're saying is exactly right, where if you know tan theta is a half, you can say theta equals inverse tangent of a half. But to avoid confusion with 1 over tangent, like Slim is saying, it's usually clearer to say arctan. We all agree that arctan just means inverse tan also. Both of these are fine. Or like they're both acceptable. I personally prefer arctan though, for the reason that you found here. Stop swearing with job. Yeah, true. Okay. And so then getting to the actual question that we were asking about, we were talking about y equals arctan nx. And just think about what the graph of actually, before we talk about nx, let's talk about just arctan of x. If okay, we'll get into nx in a second. Let's just think about what arctan of just x looks like, and then we'll say what n means. Or if you'd rather just drop it. So like what I'm trying to get to is like helping you understand what this question is asking. If you'd rather just chill out and not think about it, let me know and I'll just go on with doing my own thing. Okay. So then before we get into what the nx means, let's just figure out what this graph looks like. So I'm going to start by drawing tangent x. Tangent x looks like this, right? You've hopefully seen this. And it repeats all the way off to the left and right. And so when you take an inverse function, remember that like how that looks is it's a reflection across the line y equals x. And we have to restrict the domain because we need to follow the vertical line rule. So we're going to take just this branch in the middle here, and we're going to reflect that. So if I restart my drawing and do arctan x, once you reflect it, you get something that looks like this with horizontal asymptotes instead of vertical. Ew? No, this is a great function. I love arctan. These asymptotes are y equals pi over 2 and minus pi over 2. I think math inside is a bioethical issue. Like if a doctor messes up a calculation of the dosage of a pill on a patient on purpose or by negligence, they're held to the fire. What I see from people who have this, oh, that's how the economy works mentality, is they scapegoat these crypto bro scammers and corruption guys who scam old people for fake settlements should be held to the same standards. You want these logic show? Ooh, I really like that sock now. Yeah, I think you make a really good point there where when you mess with the economy, you're messing with people's lives, but people don't really think about it in the same way as how doctors mess with people's lives. If you develop that idea more, I'd definitely be interested in like reading about your thoughts. Favorite function is e to the x. That's a great choice of function. I'm sure Zach especially would approve. Can I prove? I think it's pronounced Thales theorem. I don't think I can, Shashank. I'm sorry. I haven't looked at the proof of that before. Weirdo, no, this is live. Okay. So that's how arctan x looks. So now, so this is just a regular old function that you've seen before. What we're talking about here is a sequence of functions. So a sequence of numbers, we might note it like this with curly braces. 1 over n from n equals 1 to infinity. As a sequence of numbers, it would look like 1 over 1, comma 1 over 2, 1 over 3, 1 over 4, ... And you'd say in the limit that it goes to 0. Oops. Is it just like sigma? Similar. So sigma is for summation. So this is called a series when you have a sigma, whereas a sequence is different. Yeah, and big pi is for a product. Sigma is for summation, so this looks like 1 over 1 plus 1 over 2 plus 1 over 3 plus 1 over 4, dot, dot, dot. And then big pi is for products. So that's 1 over 1 times 1 over 2 times 1 over 3 times 1 over 4, dot, dot, dot. Oh, thank you for the kind words, weirdo. Oh, okay, Shank. Yeah, I definitely heard of the theorem before. I'm not very good with the geometry in general. Yeah, I'm sorry. I'm sure there will be some YouTube videos on that. Cytos, can I prove the harmonic series diverges? Yes. I think the easiest way is using the integral test. You can show that this integral bounds the series from below, I believe, and then this integral diverges. That's the easiest way. The problem with geometry is that it's so geometric. Shashank, pi is not 22 over 7. 22 over 7 is approximately pi, but they're not exactly equal. My favorite proof of this, though, Cytos, involves the comparison test, though. It's a different idea. Pi is 2. That's a new one. You can group these by powers of 2. It's a little bit clearer to see if I write some more terms. I think I learned about this proof from Penn Center, or I think I remember collaborating with Penn Center when I first learned about this proof in some way. You can bound this by... This is 1 over 2 to the 0 plus 1 over 2 to the 1. So like just making a correlation between terms here. That, and then these, I think it's these two terms. I might get this slightly wrong at first. A third... One over 2 squared. Wait, what comparison am I going for? I want something that's... If I'm going to do comparison for diverging... Oh man, what's the idea here? No, it's not equal. I'm trying to... A third is more than a half. Or a third is more than a... Oh my god, a third is more than a quarter. A fourth plus a fourth, I think. Yeah, this isn't making it any sense. Oh wait, no, yes, I think I remember the idea now. Okay, and so basically I'm trying to name powers of 2 that are smaller than these terms. And so 1/8 is smaller than 1/5. An eighth is smaller than 1/6. An eighth is smaller than 1/7. And then an eighth is equal to 1/8. And you keep progressing in this way. And you're going to find a pattern where 1/4 plus 1/4 is a half. You have 4 1/8, so that's also a half. And you're just going to get a half from n equals 1 to infinity. And that diverges. That's the proof that I kind of like, because it's just kind of clever. But yeah, you can compare it with a series just a half without any ends, and that's valid. About 2 chapters from series in my calculus review, so I'm no help here. Oh, no worries, Dr. L. Yeah, because I kind of, I guess I was talking about this in response to Sidos's quote question. What sum of all positive numbers is minus 112? Oh, the Ramanujan sum? I've seen it before. I don't remember why, Shashank, but I don't think it's exactly true. Or it's the sense in which those two things are equal isn't what you would think. It's not exactly as clean as the sum of all natural numbers is minus 112. That's kind of like the clickbait version of the result, I think. Okay, number file fake news. I don't remember the exact like thing. I learned about it in one of my classes. I don't remember why it's not what you think it is, or I don't know. I don't remember. So I guess let's talk about this a bit more, Lucas. When you learn about analysis, you start by talking about sequences of numbers and whether those converge or diverge. And so for a sequence, it looks just a lot like a function, but you only plug in natural numbers. And so you can kind of use your same ideas for functions with limits and stuff. But when you get into infinite sums like this, you need to use some different techniques because sums just don't have that similarity to functions in the same sense. They still have some, but not exactly. And so one way that we can think about proving things about a series of numbers is by comparing it with a series that we know converges or diverges. So I'm going to give you the general form of what's called the comparison test for a series. Given two positive series, or sorry, I'm going to start by talking about sequences. A sub n and B sub n. If the series defined by B sub n, I guess I'm going to say 0, but it's not important, converges, and you can show that B sub n is more than A sub n, then A sub n must also converge. And I'll talk about what this means in a second, but you can also, the opposite conditional also goes where, or there's a proper term. It's not the negation, or maybe, no, I don't think it is. But you can also say if B sub n diverges and B sub n is less than A sub n, then A sub n must also diverge. And so this is a really powerful tool. You don't know what converge and diverge mean. Okay, I should have started with that then. So when you were taking limits of functions, okay, because you know about limits with functions, and so the convergence and divergence is the exact same thing. Let's take the function 1 over x. And let's think about the limit as x goes to positive infinity of 1 over x. So as we go off to the right on this graph, what's the result of that limit there? 0. Perfect. And so we just get one clean number for this limit. So we say this limit converges to 0. It means that like your limit works. Things are great. Now, what about the limit as x goes to 0? So as we're going to 0, on one hand, yeah, exactly. On one hand, we go up to positive infinity. On the other hand, we go down to negative infinity. So, you know, we just kind of, we just say it diverges because it doesn't really have clean behavior. In Dutch, we don't use the word for that. Oh, we just say like not converge. That's basically what diverge usually means. Like the formal math definition of diverge is just not converge often. Limit doesn't exist. Okay. Yeah, that's completely fair too. A lot of times in calculus classes, they have students write DNE for does not exist. Fails to converge. Yeah, that's a good way of saying it. And so a limit can fail to converge, or you know, it can diverge because of a situation like this. But there is another example that I should show you because you can diverge for a different reason too. Let's talk about sine of x. The limit as x goes to infinity of sine of x. So as we go off to the right here, we're also going to say that this diverges. Because even though it never blows up to infinity, it never settles on just one value. It always oscillates between 1 and -1. So you can never like pin it down to just one clean number. Diverge on the right limit? Yeah. So you can definitely say that it like -1 is less than or equal to sine is less than or equal to 1, but that's not good enough for convergence. Convergence, you need to say it's equal to just one thing. Does diverge mean get farther or further from something? Basically, yeah, like that's what diverge means in kind of like the regular English sense of the word. And that's basically how you think about it in math as well. It means whatever one number you try to pin it down by, you can always go away from that. Can't you say 0 because the average of the function is 0? No, you can definitely you know, that's a question. I bet there is No, like knowing that the average of sine is 0 is very helpful information, but it doesn't help you with saying that the limit converges. Because for the limit to converge, you need to be able to do the epsilon delta thing of saying that sine of x minus some limit L is always less than epsilon. But the thing is, no matter what thing you choose for L, you should always be able to find some place where you can't bound it with a delta. Will sine of n converge for integer n to infinity? I can't imagine it would, Puika. Like, that's just kind of random, right? There's no reason it would settle down. saying that like for f of x equals x, the average would be 0 as well, but the limit for x to infinity isn't 0. Well, when you say average value, Lucas, you need to say average value over what interval? So if you have f of x equals x, the average value, like if you're just going outward in both directions from minus infinity to plus infinity, yeah, sure, and like that should just average out to 0. But just because that's true, that doesn't necessarily have anything to do with the limit. Like they're just kind of separate ideas. And actually, yeah, that it's funny because if you did do the integral from minus infinity to infinity of x, you wouldn't get an integral that converges. You get an indeterminate form because you're technically talking about like an infinite area that's negative, an infinite area that's positive. Infinity minus infinity is indeterminate. It's not 0. We are getting off track. Yeah. Convergence at any interval. Oh, interesting, Puika. Not necessarily, Lucas. That's a weird thing where if you choose any finite number, like if you cut it off here and talk about these areas, no matter where you do that cutoff, you will always get 0. But if you let them be truly infinite, you get indeterminate. It's not necessarily 0. Some people would argue that it is still 0, but it's kind of as far as I know, it's kind of debated. It's an infinity minus infinity situation. Epsilon, I don't know how you would if you can. Prem, it is in the afternoon for me. It's 2:48 in the afternoon. You know, Puika, that sounds kind of familiar. Yeah, like, so we apply epsilon delta to say I guess the way you would apply epsilon delta is you would say the limit as, let's just say a goes to infinity of the integral from minus a to a of x dx. And so, oh, sorry, for average value, you need a 1 over 2a in front as well. That shouldn't affect the, well, maybe it would. Actually, probably, it definitely would. And so you can definitely do epsilon delta on this thing here. I imagine you would get something that's not going to converge, though. S and R? I think they should be the same letter, but we could call the letter whatever we want. But yeah, I guess the message that I wanted to send when we started talking about this is converge means that it settles on one clean number. Diverge means anything else. X greater for any R that exists. I'm not sure where you're going with that. Oh, you know, I remember you mentioning something about S and R where you, in your class, you were using those to mean specific things. Yeah, if x equals plus infinity, or you can say it's bigger than any finite number. So yeah, like It's probably possible to phrase it differently. And I'm probably doing it a different way than you're used to, it sounds like. But it should boil down to the same thing. Integral sine nx f of x dx converges to integral f of x. Oh, interesting. That's what weak convergence is. That's cool. Okay. So the reason we were talking about this, Lucas, was a primer for how a series. Oh, okay. I guess let's talk about how a sequence can converge or diverge, maybe. A sequence can converge or diverge. Sequences are really similar to functions. They basically are functions, just like special types. And so you can apply basically the same exact things that we've been talking about down here to a sequence of numbers, like this above here. The only thing that's different with sequences is that if the sequence shoots off to infinity, we'll say it diverges then. So like the sequence of just n, where it goes 1, 2, 3, 4, dot, dot, dot. We're going to say this sequence diverges because it goes to infinity, but we don't care about infinity in this context. We just want one clean, like, finite number. And so now a series is a sum of a sequence. And so we can talk about whether a series converges or diverges. And these don't have as direct of a correlation with functions as a sequence does. They're a little bit harder to analyze. You have to use some different tricks, basically. Because we're summing an infinite amount of things. What are you saying here? For any a that is an element in f of x equals x, a minus a equals 0. So f of a minus f of a equals 0. Integral from minus a to a equals 0. Thus there exists an x greater than a, so that x greater than r for any given value of r, and minus x less than minus r, so f of x minus x, f of x equals 0. Integral from minus x to x is 0. No worries. I'm thinking about your argument here. The answer should be no, but I'm trying to think of the reason why. I think it's because you're taking the limit before you sum things up, and you should do it, and you need to do it in the opposite direction. It's not necessarily valid to kind of swap the limit in the integral in that way. I forget if you've learned what integrals are. But there's actually a connection because integrals are basically series that go out to infinity. No? Okay. So that's going to make this harder. But yeah, it sounds like you know that an integral is the area under the curve. You've gotten that far in understanding them. So if you want to talk about the average value of a function, let me just draw a generic function. Doesn't matter what it actually is. If you want to get the average value from x equals a to x equals b, we define the average value of a function. Oh my god, I can't spell average. As 1 over b minus a times the integral from a to b of f of x. So it's the area under the curve divided by the width of the interval, basically. Yeah, exactly. You can have an integral that's finite or that's infinite in very small bricks. Exactly that, yeah. And so you can't just directly plug infinity into this thing. A and B have to be like finite numbers, but what you can do is what I did up here and just say A equals B, or A is negative B, and then take the limit as A goes to infinity. That's how you can kind of get around that. That's where I got this formula from up here. And I can just calculate this integral for you. Maybe that's the best thing to do here. So one over 2a. Now what we get for the integral, x integrates to x squared over 2. The way you can check that is you should be able to take the derivative of this and get back whatever was inside the integral. So if you take the derivative of x squared over 2, you do just get x back out. So that's how we know we did it right. But we do have these bounds to deal with too. And so what we do is we say it's x squared over 2 evaluated from minus a to a. That's what this like bar means here. And how we calculate that is, let me write the first part of the problem again. We start by plugging in the top bound, so positive a. So we get positive a squared over 2, and then we subtract out whatever we get from the lower bound. So minus a squared over 2. Makes sense? Okay, great. And so now let's just simplify this. Actually, it doesn't. Oh no. Okay, maybe like this isn't the important part of what I want to explain to you. I can definitely explain to you why this looks the way that it does. But if you don't mind, just for now, believe me that this is what you get after doing the integral, and we can come back to that. 1 over 2a, a squared over 2. Oh wait, have you been right this entire time? Is it 0? You might have been right this entire time, Lucas. I thought we were... Well, shit. That shows what I know about math. I think... That part does just give us 0, doesn't it? All right, I guess I stand corrected, Lucas. I think what I was telling you before about the average value of this out to infinity, I guess it is 0, it seems. I think we just showed it here. Okay, I guess you're right. My intuition was wrong. Yeah. Well done, I guess. So yeah, I mean, we're definitely like super off track, but I don't mind just rambling about math since it seems like you're interested in wondering about this stuff in general. So if you want, we can talk about like how the hell you actually do an integral in general, or if you'd rather, we can go back to talking about the series and sequences, whatever you're more interested in. Oh, sorry, I have a bad habit of integrals. Oh, okay. So Supreme Demon, nice name. Diffie Qs, yeah, I can help with those. Feel free to type it there in chat or put it in my Discord, whatever's easier. Okay, so okay, I think okay, maybe the way I want to explain this to you is but the fundamental theorem of calculus. I'm skipping over like the theory of what an integral is here, but I think this is getting to the heart of what you were asking quicker. The fundamental theorem of calculus tells you how you evaluate integrals. So, part one, I think it might be part two. Given a function f of x, and a function, we call it capital F of x, such that capital F, the derivative of capital F is equal to your original function. Primitive, that might be a translation issue. Primitive might be right, but like I would call this, or I would call f of x an anti-derivative because it's like going in the other direction. Rather than taking the derivative of f, we're asking what is f the derivative of, not what is f's derivative, I guess, which is a weird way of phrasing it, but we're going in the reverse direction of taking a derivative. And I'll give an example of that in a second. Then we say that the integral from a to b of f of x dx is capital F of b minus capital F of a. I think it does mean something. I don't remember what it means. And Supreme Demon, if you do post the question in my Discord, just let me know in chat too, because I don't always see it immediately if you put it in Discord. Oh, yeah, it is the same thing as anti-derivative. Yeah, same thing, Lucas. Okay, so let's think about what this says here. I'll name an example function, I guess. But let's just go back to f of x equals x. We'll take simpler bounds, so we're not going to deal with infinity. If we want to integrate f of x, let's say from 0 to 3, why not? Dx. Exactly, x squared over 2. Because you can take, you can use the, if you can take the derivative of that to get right back to x. So all the rules of derivatives that you've learned, you just put them in reverse. And so we're going to evaluate this from 0 to 3. And the fundamental theorem of calculus tells us how we do that. Exactly. X to the n plus 1 over n plus 1. That's perfect. And so yeah, so then capital F, which is x squared over 2 of our upper bound, which is 3. So 3 squared over 2 minus 0 squared over 2. So that's just 0. Who cares about it? This is 9 over 2. And so that's the area under the curve of x between 0 and 3. And we can check that using geometry. That's why I chose fx equals x, because it's really easy to verify it. So the area under the curve, let's just say that's x equals 3. It's this green area right here, and we can solve this geometrically. It's a right triangle. The bottom side, of the right triangle is 3. The right side is f of 3, but that's just 3 again. So remember, the area of a triangle is 1/2 times base times height. So we do just get 9 over 2. It's an exact match. But the, ooh, thank you for the follow, Supreme Demon. And so the power of integrals, though, is that they're not limited to just these nice cases with straight lines. You can apply them to curves. And so that's what makes integrals so cool. You posted it? Let's take a look. Oh, God. This... What are these numbers? All right, Lucas, I might need to give it a rest here. So, with the discussion that we've been having, I have to talk about this more in the future. With the Richting's coefficient. I wonder what that means. Let me put into Google Translate. Because it looks like this diffie Q is going to take me a minute. Oh, slope coefficient. Okay. Fair. In syntax error, feel free to hit me with it. I'm going to look at Supreme Demon's diffie Q first, but you can be right after. Oops, that's not what I meant. Yeah, it'd be easier to put it in the Discord. So it'll get rendered, but if you want to put it in chat, I'll put it in the Discord so it can get rendered too. Linear first order differential equation. Gonna go for a little moment, back half an hour. Okay, sounds good, Lucas. Why does your teacher hate you? Like, this is doable, it's just annoying. Can we simplify it in some way before we try to solve it? That's what I'm looking for. Only annoying problems. Yeah, that's kind of what you gotta do. It just sucks. So like we could do the integrating factor here. Is it separable? Should we try? It's not really separable, is it? No, I don't think we can separate it. You did the integrating factor? Okay. I'm going to plug this into Wolfram Alpha, just see what the answer looks like. So were you able to do this question, or do you try and get the wrong answer, or what went wrong here? I can imagine there's a lot of things that I would do wrong, so I don't ask that in a judgmental way. Okay, so this answer could be more disgusting. Uh, you're right, syntax. That does look evil. Okay. What I'll do right now is I'll copy paste it into my Discord just so it can get rendered. I'll look at it after the diffie queue. Oh, dude, I did this LaTeX horribly. Sorry, I'm just messing with my Discord right now. Okay. No worries, syntax. Let me just... I can never remember the integrating factor, how it looks offhand. Yeah! No rest for the wicked here. Mu is e to the integral p of t. Okay. I never actually learned the derivation for this. I really should. I just never really got around to it, so I have to look up the formula each time. Okay, now what is this stupid integral? Hey, Jason. I guess we have to do long division. Is there a way around that? It's an identity? If we can use a table, I would definitely love that. If your teacher doesn't mind tables, I think that's a good idea. Red Turin. Hey, thank you for the follow. Oh, true syntax. Well, we need to do some annoying stuff with the negative, but that's probably the best idea. We don't have to do actual division here. Let me get better organized. Okay, so let's separate out just the integral piece. I shouldn't do this in green. That'll be a little bit harder to read. So I'm going to say the x squared on top is equal to negative 320. Oh, partial fractions. Bruh. You're probably right. Is 324 a perfect square? I hope it is. Okay, so I'm going to say x squared is equal to 324 minus 324 minus x squared. Because those two cancel, negative, negative, positive. Okay, so that should be valid. It's 18 squared. Oh, thank God. And they have a 1 over 18 out there, so they planned that. And so the point of doing this is that we can split this fraction up based on the numerator. And if there's, I should say, if there's just like one part of this that you don't understand, let me know and I can skip right to that part. If you already understand this, then it's probably better not to waste time on it. Jason, this was the crazy part. Okay. So yeah, this is called differential equations. It's what you do like right after a calculus, like 2 semesters of calculus. I just kind of take whatever questions people want to ask in chat. So if you have a question that's at a lower level than this, there's no question that's like too easy. There's a lot of questions that are too hard, but if you have a question that's not this level, don't feel embarrassed to ask it. Okay, so the -1, that's quick enough to integrate. This thing, I think syntax error is right, and we probably need to do partial fractions. Maybe a trig sub. So then when you got, okay, good. If you gave me a second, I'd have to tell you to hold on while I work on some other people's problems or get back to you or something. Do we want to do partial fractions or trig sub? I assume they both work. Maybe let's go for partial fractions. Partial fractions on top. I don't know about that. Fembox apparently agrees with you. How do you reverse the Laplace transform? I only know what to do it using like a table. And I haven't done it in a long time. And sorry, there's been a few new faces. If you have an actual, if you don't actually hear about that, I can try to remember how it works, but there's a bit of a queue forming. I've got to work on this question, syntax error questions, and then it will be you at the earliest. And both these questions look like they're going to be involved. But yeah, for you, Red Terran and Supreme Demon, or anyone else who might be lurking who's new, I'm not the only person who streams math on Twitch. Here's a list of people who do math help in some way. Earlier today we had Slim rate us as well. And for anyone who's here on YouTube, there is Dr. Gold, who is a friend and streams on YouTube. Okay, partial fractions though. Wait. Oh my god, I gave myself so much extra work by accident. B18 plus x. 324 minus ax plus 18a plus bx plus 18b. Okay, so now x's go with the x's. Minus a plus b equals 0. 18a plus 18b equals 324. Okay. So from the first equation, we get a equals b. From the second equation, we get 36a equals 324. Surely 36 goes into 324, right? Oh yeah, because 36 goes into 360. So that's 9 if we divide each side. Nice. Math. It works. So a equals 9, b equals 9. So coming back up here, minus 1 over 18, integral 9 over 18 plus x plus 9 over 18 minus x minus 1 dx. Okay, this is integrable. Minus 1 over 18 times 9 ln 18 plus x. Now, remember, I'm doing a mental u sub here with the minus x, so we need to stick a negative sign in front of this next one. I'm going to bring it down here because I'm running out of room. Ooh, I forgot the 9. 18 minus x minus x. Okay, and now let's bring the negative 1 over 18 in. You know what? Never mind. I'm not going to do it yet. I'm going to use log identities to combine these two logs. We get 9 ln 18 plus x over 18 minus x minus x. Now I'll bring the minus 1 over 18 in. So we get minus a half ln 18 plus x over 18 minus x plus x over 18. Okay. And so e to the power of this is our very stupid integrating factor, which actually we should simplify that because e to the ln will simplify. E to the minus a half ln 18 plus x over 18 minus x plus x over 18. Hey, Suna. Okay, so first off, I'll use exponent rules to split the e up into two e's that are multiplied because it makes the next step a little bit clearer what's happening. It's going well. How about you? We're working on a pretty evil differential equation up here. Yeah, Supreme Demon, it cleans up. Once I saw the answer in Wolfram wasn't something that disgusting, I kind of suspected that we should get something that's not the worst in the world. Yeah, this is it's a very mean question. Yeah. 18 plus x over 18 minus x to the negative 1/2 e to the x over 18. Almost done. I haven't even gotten to syntax's question yet, Lucas. I'm sorry, yeah, but if you're going to bed soon, it might just be better to go to bed. If you're sticking around, you can try to wait, but this is it's not a quick question, unfortunately. No, this is from Supreme Demon. It's already to the Philippines. Okay. The way that I think I'll do this is say to the -1/2, I'll flip the inside and put an actual square root. And I think that's as simple as we can make it. You got it from here? Okay. Awesome. No worries, Supreme Demon. Thank you for the question and welcome in. Yeah. Okay. A differential equation, Lucas, it's basically I'll give the quick explanation. In a normal equation, like you might have 2x plus 5 equals 9, and you solve this for x, and x is just a number. In a differential equation, you're solving for a function y. So you might have like x times dy by dx plus x squared y equals 0 or something like that. And you're solving for y, and y is a function. That's what a differential equation is. I probably would if I had more free time, Supreme Demon, but if you have it from here, probably just move on and look at Syntax's question. And maybe come back around to Lucas if we can figure it out quickly enough. But yeah, good luck in your class, dude. I'm sorry you have to do questions like that. Sounds good, Jason. Thanks so much for hanging out and for the sub. Oh, I'm glad, Suna. Like when trying to calculate an inverse function? Kinda. We use very different techniques, but it's a similar kind of idea. 8-week online diffie-q class? Oh my god. Yeah, I mean, in that list of people that I linked before, like, and Siblix Pachinko especially loves differential equations, e2i pi, actual education, especially will be good at explaining these also if I'm ever like not around. Everyone on that list can handle them though. Exam next year for differential equations. Oh my god. Oh, are you two classmates? Do you have a DX? Oh, like you follow them all? Oh, nice, nice. Because you can involve the derivative of y. That's where it's not quite the same as an inverse function. You want to find a function y such that the original function times x squared plus its derivative times x equals 0 is what this equation says. I just made this one up off top of my head. So it's not quite the same as inverse function thing because the derivative is involved. And this comes up a lot in applications of math. So these are some of my favorite things, actually. Not this exact question that we were working on here, because this is just painful, but this field is one of my favorite things. Small blast of D's, and of course, blasted the whole thing in 2 days, wasn't too in-depth. Oh, nice. Yeah, if you're comfortable with like the baseline calculus, they're not too bad, unless you're doing questions like this. Okay, so Syntax, let's talk about your question. Because the second time I get the topic better now. We're definitely things to coming to learn like Laplace. Oh yeah. Laplace I'm very rusty on. I haven't done anything with it in years. Oops. What did I just do? Oh, I hit that button. Yeah. Let me actually there is, before I go, what is your math background / level? Reason for doing math streams? My math background / level, I have a bachelor's in applied math. I'm starting on a master's in a few months. I can normally help with things that are like calculus and differential equations and below. The reason for doing math streams is just, it's kind of like a what if thing where like, oh, this could be a really cool thing. And I just kind of found that I really enjoyed it. So I've been sticking with it. So yeah, for Red Terran and Supreme Demon, I do really love this site as a reference for everything calculus and differential equations. It's like that's the thing I just looked at for the linear diffie there. But like for Dirichlet, like this does go over the Laplace transforms too. So if you want another resource to look at, they explain, or this website explains things like in a very basic way that avoids theory. So if you just want to know what to do, this website is a really good reference that I like a lot. Laplace was also a physicist, and his name comes up in physics too, as far as I know. He also contributed a lot to math. A lot of physicists are also mathematicians, as much as mathematicians hate to admit it. But yeah, that's like the page on the inverse Laplace transform specifically. Memphis chemistry. And hopefully you know about Wolfram Alpha as well, this website. If you don't know about Wolfram Alpha already, there's no way you're in differential equations class and you've gone this far without knowing about it, but just in case, this website can solve. Okay, good. Yeah. This is a nice thing to like check your answers with. Signal processing. Oh yeah, those could come up there too, right? Yeah, so that might be a good place to start with, at least. There's, I guess, one more thing that I'll link to you to, which is if you're ever having trouble with an integral, Wolfram Alpha doesn't show you the steps unless you give them money. This website shows you steps for free. It's not as powerful as Wolfram, but it can do any normal integral that you're gonna run into. So x squared over 324 minus x squared. It'll show you the actual steps if you go there. So that's another like really good resource. Okay. Now let's look at syntax's question, I think. No worries. Oh, you know what? Third return, if you're talking about signal processing, I remember Merriweather Remark might have some more like specialized knowledge on that too. He's an electrical engineer, so if that's more your style, Mary might be able to help you out too with stuff. Okay. Now what the hell is this? Uh, your hunch might be wrong. Okay. Well, the only thing I can think to start with is factoring things and seeing how it looks. This isn't right. Seen something like this last week. We did some weird stuff with it. Where y to the n minus 1 went to yn minus 1. Like, as in multiplication? Not sure. For a constant x and y, this sure feels like it should be 1 when I write it in this form. Like, these are basically the same thing, just the exponent is offset by 1. But that doesn't matter if things are going to infinity. How did you graph this in Desmos? I guess you use a slider? For n? Oh yeah, I know, but how do you deal with bringing n to infinity? Just make it big? Okay. It was a difference equation? Oh, okay. No worries. Thank you for even trying to help with the problem. What am I writing? What? There. Wait. Oh no, okay, I'm sorry. I'm getting old and confused. It really doesn't. Just making sure I typed it in right. Okay, I think I got it. Whoa, what the fuck? It's a crazy looking function. We have to go deeper though. Huh. Okay, so which axis is which? Okay, positive x is right there, positive y is right there. And so you're talking about this y greater than x or x greater than y thing. Because we're getting this y equals negative x line of symmetry. When the Chris pyramid is I don't know, Suna. Maybe the aliens built it. If n is an integer, change depending if n is even or odd. Ooh. I wonder, because I wonder if Desmos is also, it's not always perfect at rendering things. I wonder why this difference might exist. Okay. GeoGebra? Oh, okay. Yeah, I don't know either. It's way worse. Oh. I can't say I even know the differences and how they work. Every time I use GeoGebra, I can never figure it out. I never tried to really learn it. He's using school. Oh. Call me a GeoGebra wizard. So you're saying in one part it just approaches x, in another part it just approaches y. It's not obvious to me why that would be. But I feel like I'm having troubles understanding what this graph even means. Or like what I want to try to read from it. I guess it has two lines of symmetry. Divide through by x to the n minus 1 in the limit. Okay. And you're saying if, oh, okay. Yeah, so if x is greater than y, does the positive part even matter? Oh, yeah, I guess it does. Okay, fair. No, if they have different signs, you would run into issues, right? Isn't it going to blow up to infinity? Or wait. What is negative 2 to the x as a graph? For everything, I can't visualize that. Is this not defined? What the hell? It's complex. Oh, yeah, but for integer x, you're okay. I guess that's why. Okay, yeah, fair. I forgot about, yeah, the fractional stuff causes issues. That's why I'm having a hard time with it. So if they're both negative or both positive, then things work nicely. But so here's, okay, so I think I believe you then that, you know, with x greater than y greater than 0 giving you x, and vice versa. If y is bigger, you get y. But if you've just kind of shown you can get two different results depending on the conditions, so you probably can't say that the limit has one overall value. Or I assume you can't. Oh, nice. That's kind of cool. If you add the modules, it's okay. Oh, that makes sense. Anders, mob justice. I just added this. You can vote to time someone out right now. It's probably better when chat is busier, but you can just like exclamation point mob and then you're not a mod. I doubt it would work on me. Hope you're doing well, Anders. So yeah, you could just try to time out syntax error for 30 seconds. Or Dr. L. You have to do exclamation point mob and then their name if you want to do it. No? Oh, it's too late now. I added that like just on Monday, I think. It's kind of interesting if it, or I was just hoping it would cause some like a chaos. But I feel like people are generally like, oh, maybe a little bit like too nice. We got to start some rivalries and like stir the pot, you know. um. So yeah, I don't know quite what to think about this limit syntax. So you can definitely get two different results depending on the conditions with x and y. So I assume you can't get one clean result. Do we get something interesting if x equals y? Convergence of the quotient. Oh, we probably just get 0 over 0, don't we? Yeah, I think we get 0 over 0. Hey, Jesu. Convergence of quotient between two terms in a weighted Fibonacci sequence. Finally making some progress. Oh, you're still on the weighted Fibonacci stuff. Yeah, I'm not sure where else to go with this syntax. When your algebra shenanigans live with this limit kind of perplexed. I mean, I think it'd be like, assuming there's something special about X and Y, like you can just live in, make an assumption that one is greater than the other and just analyze that. Because if you have two different weights per Fibonacci sequence, you can always just switch them and then your same analysis still applies. I assume that's how you would proceed with that, but if you're trying to get an overall clean thing for the limit, I don't know how you would do that, if that's even possible. In your paper, plan was to submit tomorrow. Like it would be Monday instead. Okay, fair enough. Good luck. It is a crazy problem. This is classic syntax error cooking. X and Y are the roots of the polynomial made up of the weights. Oh, what the hell? Oh, okay. From the doing the eigenvalue stuff. Yeah, I bet there's some type of thing you can say with like without loss of generality, we'll take like either X or Y to be the greater root. Working is a scary word. Yeah, I agree, Saitos. Yes, syntax. I, I gotta think they're still, you know, valid in doing good math if you just keep with that assumption. Because it doesn't seem like there's anything particularly special about X or Y. But even if there's something special, you can just make one assumption, analyze that, and then make the opposite assumption. If X and Y were complex, well, the same logic should still work as long as you talk about the modulus. Because I think I have to imagine that z to the n would still go to 0 if the magnitude is less than 1. Is that true? Yeah. Yes, it would. And the opposite is true. So I think the same... I think the same logic holds up. You probably would want those bars though, then. Desmos UI got updated? Like just now, or? This looks the same. I mean, like this corner up here looks a little bit different, I think. Okay, yeah, yeah. Hey, Soham. All right, I guess... Sorry, I can't really give you a better answer, Syntax, but is that at least like something? Would it be okay if I moved on, or I feel a little bit at a loss for like what else to do with that. Okay. Yeah. Thank you for trying with me. So Ham, my physics is pretty bad, I'm sorry. On the site damn near daily. Get excited when they make the folder look different. You do a lot of work in Desmos. Okay, Lucas, if you're still listening, we can go back to what we were talking about before. I don't think anyone else is waiting. Are we starting this fall? I thought it was going to be next fall for your syntax. That's exciting. Even mathematicians need heroes? True, Dr. L. Oh, you're doing it for 1 year, then taking a pause? That kind of sucks. Is that common? I feel like I'd rather do the military service first and then pause. Or sorry, do the military service first and then do university. Yeah, quote unquote peers. Touchable. Understand Gaussian row elimination for inverting a 3x3 matrix. Oh, you can't do it earlier. Oh, that sucks. So yeah, touchable. The basic idea is I'm just gonna make up a matrix off the top of my head for an example. Let's say 2, -1, 5, 3, 0, -4, 7, 1, 3. If this is the matrix you want to invert using Gaussian elimination, what you do is you make it an augmented matrix, but you augment it with another matrix. That's the identity. And what you do from here is you do normal row operations that you've hopefully already learned on this piece here. And what you do is on the left side, just do anything it takes to get the identity there. And as you do row operations, this part on the right-hand side will become your inverse matrix. So I picked kind of stupid numbers, so I don't want to go through and actually invert this, but just to show like the first step at least, you would take row 2 and subtract out, I guess, 3/2 times row 1, and you'd take row 3 and subtract out 7/2 times row 1. So these aren't very good numbers to work with, so I don't want to actually invert this matrix, but just to show it. We get 0 here. 0 plus 3/2 is 3/2. -4 minus 15/2 is minus 23/2. 0, 1 plus 7/2 is 9/2. 3 minus 35/2, oh my god, is minus 29/2. And now over here on the right side, we need to do the same things. So 1, 0, 0 on top stays. 0 minus 3/2 is minus 3/2. 1 minus 0, 0, 0. 0 minus 7/2 is minus 7/2. That's 0 and that's 1. And so as you keep doing row operations, this thing here on the right side will keep on getting updated. And so once you're all the way done with this thing on the left, it's the identity. This will be your inverse here. It is the point. So I'm going to assume that you already know row operations and could keep on reducing this to get to the identity. But that's the idea for how that works. Let me catch up with chat. I'm glad I had my math professor because he explained everything I need in the stuff my physics professor skips in lectures. Oh, nice. Red Terran. That's like a thing with a lot of people who study physics, they get curious about the math part and become really good mathematicians. Jasu is just a first timer. The baby-faced little lady. The names you gotta watch out for. Two of my friends are going to study physics, but you censored it? Yeah, physics is a bad word. Might start approximating sine or constants. REF for 4x4 or greater use Python? True, Dr. L, yeah. What happened to your augmented matrix? I screwed up the right-hand side? Did I? Oh, I did screw up the one. Thank you. Where do you put requests? Requests for questions? Red Terran? You can put them there in chat, or you can put them in my Discord if like a screenshot is easier. One minus k times 0 is definitely 1. I'm gonna need to see some more proof of that, Jasu, okay? Unbelievable. Okay. One second. I needed some water. Hey, Dia, what's the question? Comp assignment minor? Hell yeah. Be unemployed anyway. Complex differentiation? Yeah, just go ahead and tell me the question. I know the fundamentals of it. If it's easier to put a screenshot, you can put it in Discord as well. My old physics teacher asked me if I wanted to sub in-person math course in my former high school. Ooh, nice. That's a pretty cool opportunity. You can give them your limit as an extra credit question. Oh, yeah, you want to do, I guess that's a forward, or maybe you want to do a Laplace transform with that? Okay, let me do a DS question first, because I think it'll be a bit quicker, and then I can try to remember how Laplace transforms work. Aditya is asking to use the Cauchy-Riemann equations. Let me just copy and paste it. That one shouldn't take too long. Oh, well, there's a part of this that I'm going to, actually, no. Ooh. Oh. This is kind of mean. Just the reverse part? Okay. So what we have to do here is say that z equals x plus iy. There has to be an easier way. Because what I definitely don't want to do is x plus iy to the fifth. Or like I don't want to multiply this out by hand. So maybe we want to take a little detour and start with z equals r e to the I theta. So that means z to the fifth is r to the fifth e to the 5i theta. And then convert this to Cartesian. So r is... Oh, this still isn't that good. Well, no, oh, wait. Aha. I just remembered. The Cauchy-Riemann equations exist in polar coordinates. I think that's probably the better thing. Wait, when it's written in polar, what's u and what's v, though? Being possibly under 12? What the hell, Jasu? If you look it up, you can find a PDF pretty easily. It's this book right here. It's not the best book. It's just the one I've been using. It's decent, but it's not like the best one. If you just Google the name, author, and PDF, you can find it quickly. Wait, what is that in real? Well, okay, I'm not gonna call that real units, but 155 cm to inches. Oh, just over 5 feet tall. Dang, you are short. Oh god. Red Terran. Going one channel point at a time. Maybe I should put a cooldown on that. No, you're good. No worries. I'm confused how you actually use the Cauchy-Riemann equations in polar coordinates. I need to see an example. Churchill and Brown? Oh, do we use Euler's identity? Is it r to the fifth cosine 5 theta plus I sine 5 theta? And then this has a real and imaginary part? And so, yeah, if we have to do with x plus I y, I would think that, like, I would just use Wolfram Alpha to expand that. There's no way they want you to do that by hand. At least I really hope not. That would just be incredibly mean. Oh. They are mean? Okay. If you want to try and solve it first, then I'll let you try to solve it first. Too late to donate blood, so you never have to. That is a good upside. Okay, so yeah, Dia, feel free to get back to me if you get stuck. I haven't tried to actually. I don't know if it will work out the way that we're hoping, but um, hopefully it does. In the meantime, let's talk about Red Terran's question about Laplace transforms. I need to remember how the hell these things work. It's been a long time. So if someone does remember how these work and wants to bail me out, please do. I have way too many tabs open. Okay. Yeah, I don't. I just noticed the capital T as well. Maybe it's just a constant. It's a transform that you Laplace. So, Red Terran said that they're working on signal processing. So T might be something related to signal processing. Hopefully we can just take it as a constant. Right. Red Terran, I remember that. It's a constant? Okay, good, good, good. Paul might be failing me. Does he not do anything with ease? Or like this isn't even a real inverse. Oh wait, we look at the regular table and just look at the other side, right? Or does he provide a table? There we go. Okay. Bring up something involving E. But we're going from right to left here, right? Like, we need to, like, the result will be on the left. The thing we have is on the right. We're going in the reverse direction. See a table in the Discord? Oh, let's look at it. Let's use yours instead. Earn any money by these live streams? On YouTube, not at all. On Twitch, barely any. I do this because I enjoy it. Printers not so good with the colors. I might need to go back to the other one. Let's see though. Ooh, wait, no. Jesu, this capital T is just a constant. The actual variable is S. Basically, yeah, so they don't give you anything involving e's as a function, like, there's no e to the minus cs or e to the minus 2s looking thing. So wait, Red Terran, like, the function you have is the thing on the left side, right? And we need to go to the right side? Yes? Okay. You had to transform from my system inputs and calculate some stuff with it to get to the system answer. I have to reverse it. Okay. Yeah, with the table that you're given, I don't see any, like, e to a power on the left side. Which is weird. And so, at least for this table that I saw, there was an E, like, this section here has E's. It's kind of interesting. It looks like it involves the Heaviside function, which I guess that makes sense. What is LGT plus C? Times the Laplace transform of some function of t plus c. Like, I feel like we need to use this in some way. I'm just trying to figure out what the second part would be, though. It's a shift? Is that what we have? I don't know. Like, we could look at the partial fractions. We probably need to do that at some point. But like, I'm hoping to find that, I guess once we do the partial fractions, I'm hoping to find that these are each, I guess, the shifts, as you guys are calling them, or like, I hope that they match that part of it. Oh, Lucas, we had some downtime and then we got distracted again. I don't think there's nothing else in queue besides this question right now. No worries, Red Terran. This is enough to go off of. I'm just trying to remember how these work. Okay, so it should be something... I don't know, dude. Like, we could match it with this and say we'll get e to the whatever, at. I think that's what I want to do with this. We also have the constant to worry about, too. I don't know what happens with the constant. Yeah, that... I'm going to do the partial fractions eventually. I'm trying to figure out what the... what the plan is after that. Oh, sorry, I'm not showing the screen I was looking at. I was looking at the table and highlighting things. I'm just going to screenshot things that I'm planning on using. VIP, not much other than you get a nice little diamond next to your name. Looks like Dirac Delta to you. That's more than enough. Determine whether or not xdx is a maximum when x less than 0. I don't know if we're gonna have time for that today, so I just try to get through this question. Lucas is if he's still around, and then I might wrap it up. Um, the Back to the Future quote. I see you, Dr. L. Morty, we have to go back. I don't want to quote it, but there's a really funny Family Guy spoof of that. Hey, we get BS. 1.21 gigawatts. Okay, so group things by S's. AT plus B equals 0. A equals 1. B is minus T. You have the answer, but you don't know how to get there? Okay. I'm gravitationally challenged. Okay, so I get 2 minus 2e to the minus 2s times 1 over s minus t over 1 plus ts. What do we, like, I don't know what to do with the 2 that's out front also. Oh, I guess we kind of need to multiply it out completely, I think. I don't think we can keep it in this form, and then I'll maybe know what to do with it. Don't worry about it? Well, then tell me what to do, because I'm worrying about it. Oh, wait. Oh, that's what the answer is. Okay. Wait, is capital... Oh, no, I see it. Okay. Wait, so there's no heaviside function in there that I see. In the answer that Red Terran put. The convolution theorem for that product? Oh, God. I did learn about those, but a very long time ago. Okay, here. Like, I just want to transform each of these individually. I don't really know what else to do. And then like these two inverse transforms I think are pretty direct. We need to cancel the t, I think. So the first one will just become 2. Next one will be minus 2e to the minus t over t. And then these two are going to be something with heavy side, I think. Yeah, because like we have this exact thing. And then the other one is this exact thing, I think. Or it's that exact thing. I don't know which one is which. Maybe it's more like that. Thing is, Red Terran didn't include the heaviside function in the what the solution is supposed to be, so I hope they cancel out or something. I need to take a screenshot and actually bring it in because I'm not gonna remember this. So it'll be 2 times u2 of t. Or u of t minus 2 equivalently, I guess. And then that one, we probably cancel the t again. I guess I'm going to try number 27. We have a 2 out front. Hey, mouse. Yeah, I'm struggling. Struggling with Laplace. Why did I choose this profession? I ask myself that all the time, too. Or lack thereof for my profession. Hear about Oliver? He was a bit on the heavy side. I'm using that Jesse. Yeah, that's how I got the 2 on the outside. So one, okay, so that bit there translates to that, but we have to subtract out C. So minus 2. Okay, see you, mouse. Sleep well. Punish Fembox fan? Why? Um... Oh, yeah, I don't remember which notation I was taught. I just chose one. Um, so red turn, this is what I'm getting for the answer. It doesn't match what you said the answer is supposed to be. I'll copy paste it again in chat. Um, I also wonder if I didn't do this exponent quite right. I feel like it should be t minus 2 like that, the more I look at it. You think your solution in ChatGPT says the same thing? Okay. So yeah, return. I'm sorry, I have a hard time explaining it, but I basically just matched up the right side of the table with how the function you gave me looks, and then up just wrote down what the left side is. It's been so long since I've done anything with this that I have a hard time telling you why any of this is the way that it is, or being confident that I did it right. Wolfram Alpha can do Laplace transforms, I think. We could try Wolfram also. More reliable than ChatGPT. Let me see. Can it do? I swear I've seen this. Yeah! That sweet, sweet script L. Oh, but what goes where? Independent variable, function, real argument. We're gonna have to do some guessing and checking for this, I think. I don't know which one is... I don't know which one is which. 2 minus 2e to the minus 2s. 2 minus 2e minus 2s. I'm going to assume s goes here and then maybe small t goes there. I might need to switch them. I just remember having seen that fancy L. I don't know how to use this thing. I never had to do it before. Oh, that looks like a thing. Theta is the Heaviside step function. I think that matches what we got. Oh, it sure does. Okay, yeah, I feel way more confident in this now. So yeah, I'm sorry that your table doesn't seem to even go into this, Red Terran, but I think we did it right. Okay. Till you know the one with four legs. So, Luke, I was about to ask if you're here. Do you want to go back to the conversation that we were having? Assuming that's good for Red Terran's question. we all owe thanks to Jassy for saying it looks like heavy-side function. Yeah, I need to practice with it too, Red Terran. That's something that'd be good for me to get back into, because I assume I'm gonna need it. So why does e to the minus pi I equal -1? Or why does e to the I pi equal -1? I don't know how you actually derive it. Do I know? What's the justification for Euler's formula? It's the thing that I don't know off the top of my head. Oh, we just defined this? This doesn't come from something? There has to be a... You just pull this out of thin air and it happens to work? Hey, Doomwood. Just want to flex your new sticker? Hell yeah, Red Terran. I'm doing good. How about you? Oh, interesting. That's good to hear, Doomwood. I know it's just like the unit circle. I just don't like that. I guess that's the easy part of the explanation. I um so yeah, oop. Why does e to the I pi equal -1 is the question. So it sounds like you or well, let's go through it in case not, but you know, so you're familiar with the polar form of a complex number, it sounds like, where any complex number can be written in this form. And so what this actually means, it's just like the polar form in real numbers. If this is your real axis and that's your imaginary axis. Oh, I'm sorry. I just used Euler's identity without thinking about it. So the part of the explanation I was trying to justify is Euler's identity, or Euler's formula, I should say, where Zach gets his name, is e to the I theta is equal to cosine theta plus I sine theta. So when you put in chat that z can be written as r cosine theta plus I sine theta, I just plugged in e to the I theta instead because they're the same thing. And I've never actually known the justification for this formula until I just like Googled it there. Yeah. I think in part it kind of, I'm only just like learning this for the first time. It kind of seems like a thing that we've all defined and we can show that it works. But as far as where it actually comes from, you know, who kind of knows? Just, boy, there was a smart dude. And so that's what I was looking at on this Wikipedia page here. Yeah, you can justify it with series for sure. Lucas hasn't seen series. So can we go for a different one? Ah, okay. We could go through this argument. What's the other one, though? Okay, that one is a little bit weird. Yeah, so I think this one sticks to just regular differentiation. And so I think this one will be the easiest justification. So what Wikipedia is saying to do is just pretty much pull out of your ass this function, cosine theta plus I sine theta over e to the I theta. Oh yeah, sure, Doomled. Sounds good. Red Terran, thanks so much for the question. Hope you sleep well. And good luck with your class. And so the thing we want to prove here is that e to the I theta is equal to cosine plus I sine theta. And so we basically want to show that this thing is a constant. Like no matter what theta is, we want to show that it's always just one, as in like these two things canceled. And so we can do that using derivatives to justify it. So the first thing I'm going to do is I'm going to take this exponent and make it negative just to avoid doing a quotient rule. Also, I'll take a look at it. Let me glance at it quickly now. Oh, using the series. Okay, yeah. I think that's the same thing that I just looked at on Wikipedia. Thank you for that. Or sorry, it looks like the same thing. Okay, and so, oh shoot, Lucas, I hope you've seen the product rule before for derivatives. But I want to take the derivative of this. You have? Okay, good. So I'm going to start by taking the derivative of this piece and leaving e to the minus I theta alone. So cosine goes to negative sine. I is just a constant, so sine goes to cosine. And then e to the minus I theta doesn't, it stays alone, or we don't do anything with it. Wait, okay, waiting. This is a second piece. Oh, okay. So then I'm just going to tell you that the derivative of sine is cosine. and the derivative of cosine is minus sine. Viva Euler's formula? Yeah. And so now for the second piece of the product rule, we take the derivative of e to the minus I theta. Theta is the variable, minus I is a constant, so that comes down because of chain rule. So minus I e to minus I theta, and then this piece stays the same. Oh, yeah, Duma, that's a good point. Lucas just likes to explore random math. He's something like he's working ahead of his current like math class. And so the idea here must be to factor out the e to the minus I theta. So then we get minus sine theta plus I cosine theta from this piece. And then I'm going to take this minus I and multiply it into the cosine and the I sine. So we get minus I cosine theta. And then I times I is -1, but then times the minus sign flips it to a plus. And this is the exact thing that we want, because e to the minus I theta on the outside, but on the inside, minus sign plus sign is 0. I cosine minus I cosine is also 0. So e to the minus I theta times 0 is just 0. So if we can take the derivative of a function and find that no matter what theta is, it's always 0, that means our original function must have been a constant. And so what we've just shown is that this thing is definitely equal to something, some constant number c. Okay, let me explain that more. So if you take the derivative of a function and you get 0, that's just a constant, right? Like the derivative of 2 is just 0. And so we've just found that no matter what theta is, the derivative is always 0. So the function we started with must be a constant. Even though it doesn't look like one right now, it must be. And so the only thing left to do is to show that that constant is 1. And we can do that part by thinking about what f of 0 is. Cosine 0 plus, oops, I sine 0 over e to the I times 0. Well, I times 0 is still just 0. So we get 1. Oh my god, I keep writing theta. Plus 0 over 1 is equal to 1. So we know that 1 must be included in this function, but it's a constant function, so the constant has to be 1. Because we know from plugging in 0 that the function has to go through 1, but the only way that works with it being a constant function is that if the function is constantly 1. So what we end up with, if I take this equals 1, you simply want to plug in 0, because we know that 0 times I is 0. If you plug in like 1, you're going to get something weird that isn't helpful. We know that e to the 0 is 1, and that gives us something that's nice and clean. If we get e to the 2i, we don't know what to do with that yet. So cosine theta plus I sine theta over e to the I theta is equal to 1. Just one last step now, multiply each side by e to the I theta. And so that's one way to justify this. The way that I had heard of was with power series, so it's kind of neat that you can do it like this too. Yeah, do it exactly. So honestly, this even the power series way leaves me wanting for like some better way that just kind of clicks, but I feel like as far as I know, you just kind of have to accept it. Like, I wish there was a more intuitive way of showing this. I don't know, the power series just kind of feels like a coincidence, I guess. I don't know. Not like it's meant to be. And there's just something about it that makes me a little bit unhappy. I don't know. um but yeah, so back to your original question. Now that we've justified this formula, does it make more sense why e to the pi is -1? Like, you just take pi and plug it into the right side. As long as anything has a proof, my brain accepts it as true. Sort of only half more of the proof. Okay, yeah, that's fair, Lucas. That's probably a better way for your brain to work when studying math. Derived series using where's identity? Yeah, see, that would be an issue. No, you can get the series for sine and cosine. You know, you can get the series for e, sine, and cosine in the real numbers just with normal techniques without complex numbers, at least. Yeah, exactly. Just cosine pi plus I sine pi. And so cosine of pi is -1. Sine of pi is 0. So you just get the -1. ln x. Oh yeah, that one's a weird one. Yeah, pi is 180. So it's like right there on the unit circle. So in the second year, A-level stats. Ooh, nice. It is weird, right? Because you can have e to the imaginary power being a purely real number. It's just kind of weird that that's true, but it is. So if, like, what is even a to the I? I don't think it's you can always mess with it so that it looks like e to the I. I don't think there's a very good definition like what you're saying there, though, as far as I know. Uh, my stats is pretty rusty, Dumoed. Oh, well, the binomial theorem would work. That's interesting. I've never seen it with imaginary numbers, I don't think. Well, I think I've barely seen it. I don't know if it would. I can't imagine how, but maybe someone can make it work. Like the proof? Oh, good. I don't think it's the common one, but it definitely seems to work. Binomial series, not theorem. Oh yeah, I understood what you meant. I think I want to wrap things up soon, but like, Lucas, if you have a last like lingering question, I can hear it. I don't know if I have time to bite off a stats question from you, Dumoed. Especially if it's just like a for fun one. The only thing I know from television. Fair enough. Getting tired as well? Okay, no worries. We've done a lot today. Oh, especially calculus-based stats. I enjoyed my calculus-based stats class. I remember that even worse though than just like regular stats. Hey, Aaron. Learning something new. Yeah, 2 a.m. learning something new doesn't correlate well. No. Okay. I never got done the thing that I started with on the stream, but that's fine. we had a lot of good talks here. Yeah, long time no see, and I'm sorry because I'm just about to end the stream, Aaron. That's true. Do mud. Oh my gosh. Oh, I just saw you post it. Oh, nice. Yeah, that might be a fun question to look into another time. Just try and refresh myself a bit. But yeah, I won't do it right now at least. But yeah, I think that's where we'll call it. So yeah, I definitely will go back and try that one. You've piqued my interest there. But yeah, so that'll be it for the day. Yeah, Dr. Honestly, I'd be interested in the answer to that question too. School, not going study home. Oh, okay. But yeah, Doomwood, Aaron, it was nice talking to you both. I'll be back on YouTube in 2 days. On Twitch, if I either look for a raid or just call it, I'm not sure, but I'm gonna cut the YouTube stream off here. So see you later.